It recorded the video of our setup.
Yeah, I saw.
So you guys should be hearing your own voice being fed back to you.
Yeah, it is now.
You are? And you should see your own mugs too.
See the mugs. Oh, there they are.
Yeah, there you go. Hey.
So you are hearing yourself back in the. Okay.
Yep.
Okay. Guess I'll keep this here.
Okay, I think we're all good. Already?
Like 12 minutes to spare. Kind of overshot here.
There you go. You all seemed a little stressed about getting everything set up, but
I've played with OBS before, and I don't know. When it goes well, and when it doesn't, it's
yeah.
Oh, actually, we have some viewers here for this pre-funk, don't we?
11 people.
Heck yeah! Hello, 11 people.
How you doing, 11 people?
Do we have like a troll box or anything? How do we feed that back?
There is a chat. I can see it. Yeah.
Maybe I can just go to my own stream and pull it up, but not actually listen to it, but just watch the chat. Is that possible? I don't know. Maybe you can just read me.
Yeah,
or you can just read me stuff that happens. What?
There's a way to do. Well, okay, yeah, I'll just read you the chat.
Or if you can find a link that's like just the chat with no audio or video.
Just read it.
Twitch's chat has a pop-up button. Thank you, sir. I'll find it out. There we go. Ah. Thank you, Dark Sound 2903. Scott, I'm gonna Slack DM you it.
Oh, can you? Is it a private bit of data? Actually, can you just give it to me in the? Is it private?
Oh, yeah. I'll put it in Google Meet.
Yeah,
no, it's not private data.
Okay, good. Because I logged out of everything.
Good.
Yeah.
I put it in Google Meet. It's not private.
Anyway. Looking now. And actually, I do have privacy because I have like the right third of I'm on an ultra wide, and so the right third of my screen is private.
Yeah, I noticed you just dragged something to the right. Hey, Breeze.
Oh yeah, look at that! Check it out. So good.
Well, we can't see on your screen, but
you can now. I just brought it over. I brought it out of my private third.
Oh yeah. There you go. Howdy.
So good.
All right, I'm gonna send a tweet.
Oh, how are the volume levels actually on the Twitch stream? I just turned them up a little bit.
Testing. Okay, yeah, sounds good. Are we recording this? I think it's automatically recorded, right?
Ooh, I don't know. BRB though.
I recorded the setup.
I'm Oh, yeah. I just clicked record in OBS. Hope that works.
Okay.
looks good.
No, 1 minute.
Is my video, my camera on the on the stream now? It is, right?
Yep.
Yeah,
Okay, cool.
bottom right.
Yep. Great.
Okay. We'll get started in like 30 seconds. That was cool. We got 46 people here.
All right.
All right. Thanks everybody for joining. Really excited for you all to be here today. We're going to be talking about MEV Share, Flashbot's protocol for users and searchers to collaborate and for users to get paid the MEV that they generate. We're going to be starting off with a high-level overview of MEV Share, what it is, how it is designed, and how it works. And then we're going to walk through an open source code base called Simple Blind Arbitrage that the Flashbots team created and open sourced as an example of how you might write a searcher that interacts with MEV Share and uses some of its unique qualities. We're going to be walking through this open source code base, but keep in mind you should really understand this thing. You should understand its smart contracts, how to interact with it, what it is doing if you want to run this thing yourself. Or put any money into it. So without further ado, I'm going to turn it over to the legendary Scott FF to give us an intro to MEV Share. Scott?
Cool. Awesome. Thanks, Bert. Okay. So we're going to do a really quick overview of basically why Flashbots made MEV Share by kind of outlining some of the problems that MEV Share is solving. To talk about those, we're going to first discuss what Ethereum was like kind of since the beginning. We've always had this mempool of transactions, right? We've had transactions that before they land in blocks, they're shared with absolutely everybody. And very shortly after this, we had searchers that came along and realized that they could see transactions in the mempool before they were confirmed, and they can take actions on these transactions. One of the things you can do when you see a transaction before it lands in a block is that you can take this transaction and put your transaction right after it in order to take advantage of whatever this transaction was doing. As an example, the transaction could be making a very large swap order on, say, Uniswap, and that large order has created an arbitrage opportunity, and if you come right after them, you are going to be the first one that is able to collect the MEV that was created by this first transaction. With the advent of Flashbots, we were able to take these transactions and put them into a bundle, which get delivered to a relay that can bring these two transactions together at the same time. The problem comes along when searchers see these transactions and are able to, instead of putting their transaction after the user transaction, they put their transactions before, and when they do this, they can influence the behavior of the user transaction. They can say, let's say that this user was trying to buy an NFT. They could have seen this transaction in the mempool where somebody else wanted to buy the NFT and they buy it first. And in that example, we don't even require any sort of bundling, right? So that all that the searcher needed to do was to see this user transaction in the mempool and say like, oh, you know what? I'm going to do this first. And they don't even care how this transaction lands. So we don't even need a bundle for this, right? This doesn't require flashbots or bundling or anything. This just requires seeing a transaction and taking an action before they do. So the problem with the mempool is that searchers and everybody in the entire world sees it. It provides full details of all the transaction. You can see everything that transaction is trying to do and simulate it on a node and see what it's going to do on the chain when it lands there. And it means that searchers can front run these transactions, either by doing this action first or by including it in a bundle and influencing the behavior of that transaction, because that transaction is going to come second. And so it's led to users using private mempools. You've probably heard about some of these. We have like Flashbots Protect. We have a number. I remember 1inch ran one for a while. There's a large number of these where users, instead of putting their transaction in the mempool that everyone can see, there is this other pool where no details are leaked to anybody, only to the miners originally and now to the builders and validators, such that nobody else can see these transactions before they land in a block. And so users have started to give their flow here. They've given their transactions to these private mempools because no details go here. But it's kind of been a regression because now we have what we call top of block gas wars. What that means is that this user transaction lands in one block. There is now a race in the very next block for all of these other searchers, all trying to take advantage of that MEV and fighting with each other. This usually involves a large number of competitive transactions that are trying to outcompete each other and to use higher fees, and it creates a worse experience for Ethereum all around. There's a lot of wasted block space, there's high gas prices. And so the question is, coming back here, how do we create a system that enables this, right? Because in this circumstance where the searcher transaction comes after the user transaction, this user transaction is not affected in any way. The user doesn't really know or care that somebody did something after. So how do we enable this while at the same time avoiding this scenario or this scenario, right? Where the searcher can influence the transaction or just do whatever they wanted to do first, preventing them from doing it. And the answer to this question is that there's something in between a mempool and a private mempool. We're calling this service MEV share. And the idea behind MEV share is that users will give transactions to the MEV share pool, just like you might give it to a private pool, but it's going to share some of the data, not all of the data, but a very small subset of the data with a searcher and enable the searcher to look at this subset of data. In this case, as an example, the subset of data is Uniswap v2 ETH Pepe. They're saying that this transaction the user has provided has interacted with this Uniswap liquidity pool in some way. We're not saying what they're doing. They could be adding liquidity, they could be buying Pepe, or they could be selling Pepe. We don't know. But the searcher can take that limited amount of information and say, okay, well, maybe if you're interacting with this Uniswap pool, maybe we can arbitrage and buy on Sushi and sell on Uni for this exact, for Pepe specifically. But, and then you can give this back to the MEV share pool in order to see if that is a reasonable bundle to provide. But we also don't know if they were buying or selling, so maybe we need to try this transaction the other way. For that exact same transaction, we'll send another MEV share bundle back to the MEV share pool. We also might try other liquidity pools. Hey, maybe they're doing this on Uniswap v2 and there's Uniswap v3 liquidity, and this transaction has bought so much Pepe that there is now a price discrepancy between v2 and v3, and we can use that price discrepancy in this transaction, but the searcher does not have enough information to either prevent them doing what they're trying to do. They don't even know if they're trying to buy or sell, so they can't get in front of them in line. And this system will not allow them to give a bundle of transactions back that puts the user transaction second. The user transaction always has to come first in the bundle that comes back to the MEV share pool. And so this is great for the searcher, right? The searcher now has an ability to be the next transaction after a potentially interesting transaction is about to land on chain. But the question is, why would the user do this? Why would the user use an MEV share pool instead of a private mempool? What's in it for them, right? Their transaction lands first and it's unaffected in the same way. And the reason is because this MEV share system, when it lands this bundle here, let's say that this is the one that ended up being profitable because they were, say buying Pepe here. And so we were able to, to sell Pepe and buy it and kind of create an arbitrage loop with this particular route that we just guessed might be available. The the fees that are generated from this transaction here, which are often very, very high, are split inside the MEV share system, and a large portion of the fees that went into this transaction become a new transaction that is injected by MEV share that lands on chain and rewards the user by just sending them ETH on chain directly after this bundle landing. As an example of this, I have the system is live right now. It's been live for a little while, and we've seen some adoption of searchers doing this and also order flow. And here's an example. On chain, we can go look at it in a second, but what we're seeing here, remember these things it's Etherscan, so things are kind of ordered backwards. This is the first transaction. This user interacted with a swap router and performed a swap. This transaction here is the MEV extraction transaction, where they took advantage of the new price that was created based on this swap happening. This created a arbitrage opportunity that paid the builder a pretty decent amount of ETH. And in this transaction here, this is the last transaction in the bundle, you can see that the builder paid this user back, in this case, 0.038 ETH as for providing that bundle flow in the first place, right? That's the reward for giving the system the transaction as opposed to just privately relaying it. So their transaction landed without being copied by someone else, without having its execution changed by another transaction coming through it. And they also got a kickback on chain that is theirs to keep. If we look at these transactions really quick, I'm opening this up in a new tab here. Go down to Builder. Here are those 3 transactions here. I think it's worth looking at each one of them real quick. This first transaction, we see this is them interacting with this swap router. They are interacting on this refund token. Looks like they are selling this token for ETH. So I'm going to close this. I'm going to open up the next one. This is the searcher, right? This is somebody who could have been running simple blind arbitrage, or maybe a version of it they modified, or just something that operates in the same way that simple blind arbitrage does. But we can see that they were able to get 0.088 ETH in MEV out of that arbitrage opportunity, of which they gave 0.044 to the builder as a reward for including this bundle, and 0.044 they kept for themselves, right? This is this B820, B820. So they paid themselves 0.044 ETH as a reward for landing, and they only had to pay 0.01 in order to in transaction fees. And so keep this number in mind, 0.044. If we go back to that final transaction that pays out the user, I'm opening this up in a new tab. So of that 0.044, the builder kept a small portion for themselves and paid 0.038 ETH to the originator of that transaction that created the MEV. I think that's a good time to stop and maybe ask for questions or see if Bert or Brock want to chime in here on anything.
We had somebody asking for slides in the chat, if you don't mind sharing those.
Of course. How should I share them? So I'll give them to you. I'll give them to you, and I'll just put them right there, right?
Yeah. And then I got it. Yeah. Cool. Let me see if I can get that. Okay, looks like they're free.
Yeah. So the question about the average rebate. So this is a very, very new system. We have just. Oh, that doesn't work. Oh,
no, it worked for me.
Yeah, but you might be. I think that's because you're Flashbots. Oh, that should work. I think it should work.
No, I opened it on Anon tab. So.
Okay. So, the question is, it's a good question. What is the average rebate? The average rebate is still kind of being determined right now. This is a brand new system, and it's been live for some number of weeks. We've had several, I think probably on the order of 40 or 50 kickbacks so far land on chain, somewhere in that neighborhood. So it's a very, very new system. We're still attracting order flow. We're still attracting searchers and building this marketplace of people providing order flow and searchers that know how to operate on that order flow to extract MEV that has a majority of it going back to the user. I will say that there's recently been a 1.2 ETH kickback that occurred several days ago. It was like there was an Oracle update in one of the transactions. That Oracle update went through our order flow system, and the person who updated the Oracle got 1.2 ETH back as a reward for one searcher who wanted to put a transaction immediately after it. If everyone is using the service becomes a semi-public. I mean, yeah, it is semi-public, right? Actually, that's a really good question. Semi-public. Let's talk about what semi-public means. And to do that, we talked about this component here, right? This stream of transaction hashes with hints about what is happening in those transaction hashes. We can actually pull that up in our browser very, very easily. It's one of the kind of the cool things about MEV Share. So I'll pull that up right now. You just go to mevshare.flashbots.net. This is an endpoint that will stream the transaction flow to anybody who asks for it. So if we just sit here and wait for a second, there we go. We have the transaction hash, and then we have logs here. So the MEV Share system, actually, let me increase the font size here a lot. We have the MEV system simulated the transaction that was sent to it, grabbed the address, grabbed one of the log topics, and sent that along in this endpoint that others could look at that, decide if they wanted to try to backrun it with several transactions that could extract MEV and feed it back to the system. So here we can see another transaction that all that it shares is the hash. So when we say programmable privacy, we mean that whoever submits the transaction is the one that is allowed to determine how much of the transaction is leaked. In this case right here, they said nothing. Like the only thing you can leak is my transaction hash. And from that, searchers would have a really hard time landing opportunities. But if a searcher knows the time frame of an Oracle update, which was the case a couple days ago, just by knowing the time frame, is that, hey, in this 10-minute window, just knowing the hash, I will try to backrun everything in this 10-minute window and in order to extract MEV, and it ended up being successful for them. So they were able to backrun something without knowing anything about it except for the general time frame of it being released. So here we see all of this data that is being streamed that is partially anonymized. Here we have, let's see, is there anything more? Do we have anything that does selectors? Yeah, we haven't seen it. There's other things that can get shared besides logs. There's the contract address you interact with. There's the function selectors of the call data. And I think that's it, right? I should have the... Actually, can you post a link, Brock or Bert, to the MEV Share documentation? I'm pretty sure there's one more that I'm forgetting.
Yeah, I got it.
Cool. Yeah, here we go. So here's somebody who sent a transaction that was willing to share. Oh yeah, here we go. Full call data. So they were willing to share what they were sending it to, what the function selector was, but not what contract address it was destined for. Yeah, that's pretty interesting, right? So they get to choose what gets shared, and it can be up to the wallet that might be making these determinations. It could be up to the user, but the idea is that the user gets to control instead of being stuck with this this kind of dilemma that we had before of, are you going to go to the mempool or are you going to go to the private mempool? The users now have more control over what gets shared ahead of their transaction landing completely on chain.
Maybe we take one more question, move to the code.
I think sounds good.
Reese says, so I could expose my transaction hash and potentially get a kickback if someone extracts my MEV. Someone extracts MEV, post my TX, but since it will be harder for them to do so, I also have a higher chance of claiming any post mine.
Well, yeah, I mean, if MEV extraction is a bit of a it's kind of a bit of a specialty, right? I mean, it's fairly difficult to do, but I mean, MEV is created, by the way, by, let's say that you are making a large order for ETH Pepe and you go straight to one Uniswap market to do so. Let's say you only do Uniswap v2, even though there's like 3 other very good markets out there to choose from. I mean, MEV is really created because that transaction really should have gone to all the sources and bought enough that it kind of kept the price. You got the best price for the user. So a lot of times the reason this MEV is created is because the user didn't create the right transaction in the first place that could have that could have kept all of these pools more in a like price parity. And so yeah, if you can extract your own MEV, you probably just create a different transaction in the first place. It is more difficult. The less you share it, the more difficult it is for searchers. And so the less kickback you get, and you might not get any kickback, right? Because MEV shares will also just bring your transaction to the chain on its own without any sort of a kickback. If nobody has bid on your transaction, which is probably the normal operation of the system, right? Because if you're just saying, hey, I want to send my friend 3 ETH, you're not creating any MEV. There's nothing that anybody can do right after that they couldn't have done before. And so, there's a set of transactions that can extract MEV, and yeah, if one of them, users don't generally extract their own MEV. They would have created a new transaction in the first place, I think is really the answer there. Okay. So now that we understand kind of this component here, right? So this component that reads this stream of transactions, looks at them, and then dreams up bundles and their own transactions that could go after the target transaction that may or may not make money based on the limited information they have. I wanted to introduce you to a simple repo. Let me shoot it in GitHub first. We're calling this, so the first thing we created a long time ago was called Simple Arbitrage. It was one of the first before the MEV share, like when Flashbots first launched. So this is simple blind arbitrage because this uses MEV share and using limited information such as what address did this interact with without even knowing if it bought or sold, is able to make arbitrages by just sending a large number of them back to the MEV share system, right? Just like here, right? So this is basically what the system does. Simple blind arbitrage reads, creates 2 bundles looking for like, hey, do I sell this way? Or hey, do I sell this way? And provides them back to MEV share. Okay. So I already have cloned this and pulled this up in an IDE. And Brock or Bert, if you want to chime in here, I'd be more than happy to have some backup here. But the whole system, let me just kind of just like walk through the code really quick just to show you like how little of it there really is. So there's this index. What was that?
Yeah, here to chime in.
Okay,
wherever.
Awesome.
But,
yeah, if you please feel free to interrupt me. But the first thing that I really wanted to draw your attention to is just like how little there really is to this code. So there's this index which just sort of like looks at some options, sets up a few network connections, and then has this little loop here where it kind of does some evaluation. There's a little bit of code over here kind of for how to like look at Uniswap pools, and the bundle executor, which formulates the request, right? Those little like two transaction bundles, and sends them off to the matchmaker as a potentially profitable bundle to include. But you can see like this thing's like half comments. Like there's really not a lot to it. This isn't an overly complex system. And I do want to take a moment here before we get started to say that running this in its current form is almost certainly not profitable because there are many people who do this and there's only a limited amount of MEV out there. Like the real reason that I wanted to go through this isn't to convince you to just clone this and run it. This is a really good place to build from and apply other ideas that you have for alpha about, hey, maybe if I look at it this way, hey, maybe if I instrument this pool over here, or maybe I, buy the tokens and take on some liquidity risk and sell them in the next block. Like this is really a framework to build off of, and that's why it's so simple, is because it really wanted to be easy to understand and extend without being profitable in its current state, because it's too easy for everyone to run it and just use the same logic, and all the MEV kind of competes with each other and everything gets bid down to no profit whatsoever. So this is definitely not a get rich quick presentation. This is a something that I wanted to show to help you build your version of what this might be, or to adapt this to some other some other strategy.
I did add a branch, if you're interested, that uses a flash loan for liquidity. It needs a little bit of changes to the index.js file in order to make this work. But if you're watching this and you don't want to get started with your own capital, you may be able to use the flash loan in this with this as well. So you're not putting any of your funds at risk. You can just deploy a contract, get started.
Mm-hmm. Yes. Yep. But still, getting started is not a decision to be taken lightly, because, well, for instance, one of the first things you need to do when you are interacting with the system is you need to come over to this environment file, right? So we are in, this is the, zoom in there, I don't know if I can zoom in. So this is the file structure of the system, and under execute, which is where all of these scripts live, there are a bunch of files here. One of them is env. So in this case, we need to, we need to have an RPC connected to. You might use Infura. Most people who are searching have their own high performance servers that they use, that they operate. This private key is not valid. There's just some bunch of data that I found. But you need to literally go get a private key that has money in it and copy and paste it and put it in here. And so that is a very kind of dangerous thing to do, right? This is a hot key that you're running in here. You could be accidentally committing things. You could go to git push something to GitHub on accident, and all of a sudden your private key is compromised. So be very careful with that. And we also need to deploy a contract that is included in this repository that I think we should probably go through first. And then put that contract address here. So these are some fairly technical steps that are needed in order to set this up. I think it's worth talking about the contract first. Actually, Bert, did you want to kind of go over the contract, or did you want me to do that?
Happy to go over the contract. Yeah. You want to pull it up?
Yep, it's right there.
Yeah. So I was a bit lazy in my Forge deployments, and there are a couple different contracts here. But in the simple blind arbitrage root repo, you go to source and then blind backrun.sol in order to find the relevant code. And there's another one for debugging and testing, which is useful if you want to run the Forge scripts or do any sort of debugging of this and change it around. And if you look through the code, the main path that matters here is this one function, execute arbitrage. It takes in 2 pair addresses and a percentage to pay Coinbase of which comes up later. And remember, the context in which you're calling this function is that you have partial information that has been leaked by the matchmaker about a user's transaction. So the matchmaker will tell you, hey, a user is swapping on the ETH USDC pool on Uniswap v2 or Uniswap v3, but it won't tell you how much they are swapping. And just with this information of the pair that a user is swapping, you can go and find, another pair of the same type, ETH USDC on SushiSwap if the user is trading on Uniswap v2. And look for an arbitrage between these 2 different pairs, all on chain. So that's what we're trying to do here. We take in 2 pair addresses and we're looking for an arbitrage between them, doing all those calculations on chain. We start by setting up some structures. So you got to tell Solidity that these things are pairs, and we get some data from them. If you go to the get pair data function, Scott, we can see what data we're returning here. So we give it a pair, and what we get back from it are the reserves of that pair. So the amount of tokens, of ETH or USDC, to keep on using this example. We log whether a token is WETH or not. So you want to know which token, either the first or the second in the pool or the pair, is WETH, because this is helpful in calculating the arbitrage and knowing which direction to trade. And we calculate a price, which is just the we calculate a price, which is the reserves divided by each other, and then doing some stuff to handle decimals in the token. So we have this information, we return it back, and we start calculating our arbitrage further in. Where a lot of the magic happens in calculating the arbitrage is this function called getAmountIn. Long story short, Uniswap v2, since it is a relatively simple mathematical formula for a DEX on-chain, you can actually calculate an optimal trade given the state of two Uniswap v2 pools, and down to the single way with the optimal amount. I won't run you through the exact code here, but know that this getAmountIn function uses that optimal trade calculation and calculates it all within Solidity. It's like fairly complicated math. There's a numerator part and a denominator part. One of the complicated parts of it is handling tokens, because your tokens may have different decimals and you need to make sure that they don't overflow or underflow at some point. But this getAmountIn, again, takes the state of the pairs that we had just gotten a moment ago, and it calculates what the optimal trade is on chain using this somewhat simple mathematical formula, which is complicated to look at, written in Solidity. Okay, so we have the optimal amount in. Of course, we need to know more than that. We need to figure out how much am I going to get out for this, given what we sent in, and then how much am I going to get out on the other side. But first, in order to make swaps on Uniswap v2 pairs, you actually have this interesting thing where you need to optimistically send the tokens before you call the swap function. So this line that Scott has highlighted is us sending the amount in to the first pair address that we are trading on before we call swap on it. Okay, so we have our amount in, we transfer it, we calculate below depending on, then depending on whether the pair, the first token in the pair is WETH, or the second token is WETH, we change sort of which token we are trading and buying on first. That's the if statement there. We sent in our WETH to the first pair. We calculate how much we're going to get out from the first pair given that amount in WETH. That's first pair amount out. Given how much of the token in first pair amount out that we're getting, we then calculate the final amount out, which is the WETH that we get on the other side, completing the arbitrage. And then first pair dot swap and second pair dot swap are us actually executing these trades on chain, if that makes sense. Again, note that there is this interesting thing about how Uniswap pairs work and their swaps, where you need to send tokens to them first and then call the swap function. So we first send WETH to the first pair. On the first pair, when we make that swap, we set the recipient address of the tokens we're swapping out of the first pair to equal the second pair. And then we call swap on the second pair, setting the recipient address to be our contract for execution.